Hi friends, welcome to our YouTube channel Knowledge Academy. The main aim of this place is to teach or discuss the previous year gate questions of all electrical subjects in a very detailed manner. If you are seeing this video for the first time in this channel, then please go back to our playlist Gate Previous Year Questions and see the lectures from the starting so that each concept can be understood in a very clear manner. If you like the content of this lecture, then please do like, share and subscribe our channel, and don't forget to press the bell icon button so whenever we upload a new video, the notification will come directly to your mobile phone. The main aim of this lecture is to teach or discuss the 10 numerical problems of network theory, which are the previous year 8 questions. So now let's get started. In the previous lecture, we have solved up to 60 numericals. So now we will do more 10 numericals. So the first question is, it is the 61st question. This question it says that these three elements are a part of some circuit. Means they are not given the circuit after this and after this also. So we don't have to construct the remaining part of the circuit. So this network, these three elements are part of some circuit. So in this branch there is a 10 ampere flowing, and in this branch there is a 8 ampere flowing. So we need to find the power absorbed by this. The total power absorbed by these three elements we need to figure out in this circuit, and this question is given in the GATE 2014 for 1 mark. So we need to figure out the power absorbed by these three elements in the circuit. See here, whenever in a, suppose there is the element, right? In this element, suppose this is a positive and this is negative. So let me consider this as some element E. So whenever the current flows from positive to negative, then this element is going to absorb the power. So this element is going to absorb the power. ABS means absorb the power. If the same element E, if the current flows from reverse direction, it means if the current goes from negative to positive, then this element is going to deliver the power. Suppose if we assume power absorbed is positive, then the power delivered has to be the negative conversion. So if suppose P deliver, if we got an expression for P, let assume if the element is going to absorb, let me assume that suppose this element is going to absorb some 5 watts, then this element is going to absorb negative 5 watts. Means, see here, if this element is going to deliver 5 watt, means we can say in another fashion, this element is going to absorb power of minus 5 watt. See here, so therefore we can easily tell that this element is going to deliver the power. Suppose if P absorbed is, let me assume it is 2 watt, then we can write in another fashion, this element is going to deliver a power which is negative, which is a reverse. Means if you see, suppose in any problem, suppose some element is going to deliver a minus 2 watt, then we can easily figure out that this element is going to absorb power of plus 2 watt. So let me assume the current in this branches, is I. See here, at this particular node, there is a current of 10 ampere which is flowing into the node, and there is a current of I ampere and another 8 ampere are flowing outside the branch, outside this particular node junction. So by KCL, the sum of incoming currents is equal to the sum of outgoing currents. As there is only one current which is incoming to the node, so let me assume this is a 10 ampere, incoming current is 10 ampere. So outgoing currents are, which is I and the another 8 ampere. So therefore I plus 8. So if we figure out the value of I is equal to 10 minus I, which is 2 ampere. So therefore the current in the 15 volt is, which is 2 ampere. So I will write I is equal to 2 ampere. If you see carefully, in this 100 volt source, the current is going from higher potential to lower potential, which is positive and this is negative. So this element is going to absorb the power. So therefore P absorbed by 100 volt is P absorbed. So this element is going to absorb a power which is product of the voltage and product of current. So the voltage is 100 volt and the current is 10 ampere. So therefore we will get 1000 watt. 1000 watt amount of power is absorbed by the 100 volt voltage source. So if you see here also, this is negative and this is positive. So the 80 volt voltage source, the current is going from negative to positive. So this element is going to deliver a power. So the power which is delivered by 80 volt source is equal to the product of the voltage and the current. The voltage value is 80 and the current is 8. Therefore 80 into 8. Therefore the product of 80 into 8 is equal to 640 watts. But we need to calculate the power absorbed by the 80 watt. So therefore power absorbed by 80 watt is 80 voltage source is equal to, which is the negative of the power delivered by 80 volt. So therefore it is minus 640. Means the power delivered by the 80 volt source is 640 watt, but we need to figure out the power absorbed by the 80 volt, which is the reverse, which is the negative of the previous value. Therefore minus 640 watt. So the remaining element, this element, see here, this is negative and this is higher potential. So in this element, the current is going from negative to positive. So therefore this element is also going to deliver the power. So therefore P delivered by 15 volt. We need to find. So the voltage is 15 volt and the current is 2 ampere. So therefore product of the 15 volt into 2 is equal to 30. So therefore 15 into 2 is equal to 30 watt. But we need to figure out the power absorbed by the 15 volt. So therefore power absorbed by the 15 volt is the negative of the previous value. So the power which is absorbed by 15 volt, which is minus 30 watt, which is the reverse of the previous value. So therefore this element is going to absorb a power of, this voltage source is going to absorb a power of 1000 watt, and therefore the 80 volt source is going to absorb a power of minus 640 watt, and finally the power absorbed by this 15 volt is equal to minus 30 watt. So in this question we need to figure out the total power absorbed by these three elements. So therefore we need to do the summation of this one and the 1000 and minus 640. So therefore finally the power absorbed by the three elements is equal to individual sum. The power absorbed by the 100 volt is 1000, right? 1000 watts. And the power absorbed by the 80 volt is minus 640. So minus 640. And the power absorbed by the 15 volt is minus 30. So if you do the calculation, you will get 330 watt is the final solution. So therefore power absorbed by these three elements is 330 watt. So after solving the previous problem, now let's move forward to do the other problem. The problem number is 62. This problem says that there is a bulb. This bulb has a rating of 40 watt for 240 voltage. Means whenever we supply 240 volt, the bulb is going to give a power of 40 watt. Suppose if we give less than the 240 volt supply, then the bulb will dissipate a power which is less than the 40 watt. Suppose if we given a voltage which is more than the rating of this voltage, then the bulb is going to give more power. But if you supply more supply than the rating, then the bulb may get damaged. See here, for this question, there is when the resistance of the bulb is 120 ohm. The resistance of the bulb is 120 ohm at temperature is equal to 26 degrees centigrade. Means at a temperature of 26 degrees centigrade, the bulb has a resistance of 120 ohm, which is given in the question, and it has a temperature coefficient of, which is denoted by a symbol alpha, which value is 4.5 into 10 to the power of minus 3 per degree centigrade. So we need to find, suppose when we given a rated supply 240 volt, the bulb is going to dissipate a power of 40 watt. So at these conditions, the bulb has some resistance and has some temperature. Because of heating effect, the bulb has some temperature. So we need to find the value of the temperature when the bulb is on. So this is the main agenda of this problem, which we need to find when the bulb is on. it going to dissipate a power of 40 watt when we supply voltage of 240 voltage. So we need to find how much is the temperature of the bulb, that we need to figure out in this question. And this question is given in the GATE year 2014 for 2 marks. So let's get started. See here, this is the resistance R1 120 ohm at temperature 26 degrees centigrade. See, suppose we have given a 240 voltage supply and the bulb is going to dissipate a power of 40 watt when bulb is on, right? So I have given a voltage which is 240 watt. So the bulb is going to dissipate a power of 40 watt. So now at this on condition, I need to find what is the resistance of this bulb. So let me assume the resistance of the bulb is R2. So therefore R2 is equal to, we know that the relation P is equal to V square by R. V square by R. So R is the resistance of the bulb, right? So let me assume it is R2. So R2, we need R2, right? The resistance of the bulb. So V square by P when the bulb is on. So V is how much? 240 voltage. So 240 whole square. 240 whole square by P. P is 40 watts. So if you do the calculation, you will get R2 is equal to 1440 ohm. This is the resistance of the bulb. This is the resistance of the bulb when we give a supply voltage of 240 volt. So the bulb going to dissipate a power of 40 watt. At this condition, the bulb has a resistance of 1440 ohm. See here, R1 is equal to 120 ohm and temperature of 26 degrees centigrade. But here you see the resistance is 1440, means this R2 is more greater than R1. So in the property of a conductor is, whenever there is an increase in temperature, the resistance is going to be increased. I am repeating it again. In a conductor, the temperature coefficient is always positive. It means whenever there is a rise in temperature, the conductor has a resistance value is also increases, means directly proportional. So dR by dt is always positive for conductors, means as the temperature value is increases, the resistance value also get increases. See here, I am drawing the graph with respect to temperature and the resistor. See, so whenever the temperature is increases, the graph is going to be like this. See, this is a degree centigrade. The unit is degree centigrade, and the unit is ohm value for resistance. So whenever there is a rise in temperature, the resistance value is also in straight line. It is a straight line which has an intercept, means at even zero temperature there is some resistance in the conductor. So let me assume, suppose this is a temperature T1. At this temperature, I know the value of the resistance is R1. So we need to find the value of T2, which has a resistance R2. So from the graph we can easily see that as the temperature is increases, the resistance value is also increases. So therefore R2 is greater than R1. So we need to find the value of R2. So this can be easily figured out by a relation, which is, I will give the relation. Remember this relation. If you remember this equation, then it is very easy to solve this unknown parameter. And I will derive this relation, how to do it in my theory classes in the coming days. So until that time, just remember this equation. In the coming classes, in the coming days, I am going to teach you how to derive this relation in my theory classes in network theory. But until now, please remember the equation. R2 is equal to R1 into 1 plus alpha T2 minus T1. Means R1 is the resistance of the bulb at temperature T1. R2 is the resistance of the bulb at temperature T2. So R1 is 120 ohm. So R1 is 120. And R2 is, we already know it is 1440. And 1 plus alpha. Alpha is already given in the equation, which is 4.5 into 10 to the power of minus 3. And the temperature T2 we need to figure out. So it is an unknown parameter T2 minus T1. T1 which is already given the question, which is 26 degree. So therefore you can write it as 26 degree. So in this equation the only unknown parameter is T2. So we need to figure out the value of the T2. So therefore T2 value is 2470.45 degrees centigrade. So the value of the temperature T2 is 2470.45 degrees centigrade. So at this temperature, see, means when we give a supply voltage of 240 voltage, the bulb is going to dissipate a power of 40 watt. So now the bulb has a temperature which is 2470.45 degrees centigrade. So therefore T2 is greater than the T1. So this is our required solution. This is what we need to find in this question. So this is our required solution. See, after solving the previous problem, now let's move forward to do the another question. This question is the question number 67, and this question says that there are two coils. They are connected in series fashion. So whenever the two coils are connected in series, they can be connected in two ways, which are series aiding and the series opposing. Series aiding means the entering current, the current which is entering the dot in the first coil has to enter in the same fashion as the first coil. See here, the current is entering the dot in the first coil. Similarly, the current is entering in the second coil through the dot. So same fashion is happening. That is why this is called as a series aiding. When come to this connection, the current is entering the dot in the first coil and the current is leaving the dot in the second coil. So therefore, this connection is called as a series opposing, and this connection is called as a series aiding. So whenever there is a series aiding, the equivalent, see in the question they are given the equivalent induction is 380 microhenry for the series aiding, because in series aiding the equivalent inductance is more when compared to the equivalent inductance in the series opposition. So in the series opposition, the equivalent inductance is 240 microhenry. So in this question, M is the mutual inductance and L is the self-inductance of the first coil and L2 is the self-inductance of the second coil. So we need to figure out what is the mutual inductance between these two coils. When they are given the equivalent inductance in the series aiding is 380 microhenry and the equivalent inductance in the series opposition is 240 microhenry, because series aiding has an equivalent inductance which is more than the series opposition equivalent inductance. So whenever the two coils are connected in series and if they are connected in a particular fashion which is series aiding, then the equivalent inductance is equal to L1 plus L2 plus 2M. So L equivalent is already given in the equation which is 380 microhenry. So therefore I am going to write as 380. So therefore L1 plus L2 plus 2M is equal to 380 microhenry. So this is the first equation. If you see here, these two coils are connected in a series opposition. So the equivalent inductance will be L1 plus L2 minus 2M. So by these two equations we can see that this equivalent inductance is more when compared to this one, because there is a negative sign and it is a positive sign. So but already in the question they have given the equivalent inductance is 240 microhenry. So this is going to be our second equation. So we need to figure out the value of the M. So we can easily figure out this by calculating by doing operation 1 minus 2. If you do operation 1 minus 2, L1 plus L2 and L1 plus L2 will get cancelled. So 2M minus of minus 2M will become 4M. So 4M is equal to 380 minus 240 will be 140. So therefore M is equal to 35 microhenry. This is our required solution of this problem. See here, I will repeat it again. So whenever the current is entering the dot in both the coils, then this is called as a series aiding. Whenever the current is entering in dot in the first coil and if it is leaving in the other coil through the dot, then this is going to be the series opposition. As the two coils are connected in series fashion, that is why I am telling they are connected in the series. So therefore M is equal to 35 microhenry. This is our required solution of this problem. So after solving the previous problem, now let's move forward to do the another numerical. This numerical number is 64th. And this question is a very easy question. So let me solve this question. See here, there is a voltage source which value is 300 volt, and there is a resistance R which is given by equation 25 plus I by 2, where I is the current flowing in the circuit, and direction is also given in the question. And we need to figure out what is the value of the current which is flowing in this circuit. And this question is given in the year GATE 2014 for 2 marks. So now let's get started to solve this problem. See here, they already given the equation for the resistor. So the resistance R is equal to 25 plus I by 2. The 25 plus I divided by 2. So now I am going to multiply by 2 on the both sides. So therefore 2 into R is equal to 2R, and 2 into 25 is equal to 50, and 2 into I by 2 is equal to I. So now I need the expression for the current I. So therefore I is equal to 2R minus 50. So now I got the expression for the current I. See, now I am going to write KVL in this loop. So current always travels from higher potential to lower potential. Therefore this is the positive sign and this is the negative sign. So I am traveling with KVL in this closed loop. So when as per KVL, I am writing the KVL, the sum of algebraic sum of voltages in a closed loop is equal to 0. So I am traveling from minus to plus. So therefore there is a rise in potential which is plus 300. And after traveling up to here, I got plus to minus. So there is a drop in voltage. There is a drop in potential which is minus. So minus I into R. The voltage drop is I into R. Therefore I into R is equal to 0. But if you see carefully, the value of the current I is already got in this expression, which is 2R minus 50. So therefore 300 minus I value is 2R minus 50. 2R minus 50 into R is equal to 0. So now what I am going to try, I am going to multiply R in this inside term. So therefore 300 minus 2R square plus 50R. And if I do the negative sign, if I multiply this equation by the negative sign, I am going to get 2R square minus 50R minus 300 is equal to 0. If you see carefully, this is a quadratic equation. Quadratic equation has two roots. Therefore, if you solve this equation carefully, you will get two values, which is R is equal to 30 ohm and other value is minus 55 ohm. If you solve this equation carefully, you will get R is equal to 30 ohm and another one is minus 5 ohm. As the resistance is only the positive value, the resistance cannot be negative. So therefore, the value which we got, which is this one is wrong and this is the correct. This is not our required value, because the resistance is always a positive value. It cannot be a negative value because the current always goes from higher potential to lower potential. So therefore, the current is always positive. If you do this operation, you will get always R value is always a positive value. It cannot be a negative value. So therefore, the negative value is not our answer. So our answer is only R is equal to 30 ohm. So now we need to figure out the value of the current I. If we want to find the value of the current I, if we need to find the value of the current I, as there is an equation which is relating current and the resistor. The resistor value is 30 ohm. So if you substitute the value of the R 2 into 30 minus 50. So therefore 60 minus 50. 60 minus 50 is 10 ampere. Therefore the current which is going through this circuit has a current value which is 10 ampere. So and the resistor R value is 30 ohm. So we have figured out our required EM in this problem. So after solving the previous problem, now let's move forward to do the another numerical. The numerical number is 65, and this question is the most beautiful and also the most interesting concept. So let us focus more and solve this problem. If you see carefully, this circuit has an AC source. This circuit has an AC source which is supplied to this whole circuit. This circuit has two capacitors that the values are XC1 and the XC2 are the capacitor reactances, and there is a resistance of 1 ohm. The current through this 1 ohm and the reactance XC1 is 2 ampere, and the current through this AC source is 10 ampere, and there is a load which is an inductive load because there is a resistor and there is an inductance. So that is why this load is an inductive load, and the voltmeter will read a voltage of 200 volt across this load. All this is given in the question, and the power absorbed by the circuit, and the power absorbed by this whole circuit is 1 kilowatt, which is already given in the question. So the main aim of this question is to figure out the load inductance, means the load reactance. How much is the inductive reactance of this load, XL. This question is given in the GATE year 2014 for 2 marks. So now let's do this problem. See here, they are already given that power is equal to 1 kilowatt, which is observed by this circuit. So as already the capacitors and inductance does not absorb any active power. They only absorb reactive power or deliver the reactive power. Inductances absorb the reactive power and the capacitor delivers the reactive power, but the capacitor and the inductor does not consume any type of active power. So the remaining elements in the circuit are only resistor. So therefore the resistors are going to consume the active power. Means therefore the power absorbed is 1 kilowatt. It has to be absorbed by only 2 elements, which are resistor in this case and the resistor in this another case. So therefore the power absorbed is, see, the current in this 1 ohm is 2 ampere, right? So in this is 2 ampere. So now if you see carefully here, there is a 10 ampere through this source. So therefore here also there is a current of 10 ampere. And similarly the current in the voltmeter, ideally the voltmeter has a resistance which is ideally infinity value. So therefore the current in this voltmeter is 0 ampere. So the current in the voltmeter is 0. So the incoming current is the arithmetic sum of 2 outgoing currents by KCL. So if this is 0 ampere, so then this has to be 10 ampere. So similarly in this branch is also 10 ampere. So in the load is also 10 ampere. As in this branch the current is 0 ampere, so therefore here also the current is 10 ampere. So by this, in the resistor 1 ohm the current is 2 ampere, so I square R. I square means 2 square into R plus. If you see carefully in the resistor, another resistor R, the current is 10 ampere. So therefore 10 square into R. The value of R is not given, so but P absorbed is 1 kilowatt, right? So 1 kilowatt means 1000 watt. So now we need to find the value of R. So 2 square 4. 4 plus 100 R is equal to 1000. So if you find the value of the R by this expression, 1000 minus 4, 996. 996 by 100, you will get 9.96 ohm. So this is the value of the resistor R. But we need to figure out the value of we need to find the value of the XL in this case. So if you see carefully here, the value of the current is 10 ampere, right? So as there is an inductor, let me assume the volt. See, I will draw the inductive part here. I will draw only the load part here. If you see carefully here, there is a load, right, X, and there is a resistor R. The current is 10 ampere, right? In this way, the current is 10 ampere, and it is a value of XL, and the resistor is R. See, the voltage drop across the resistor is VR, and the voltage drop across the inductor is VL, and this is the voltmeter reading across the combination. So this is the voltage drop. This is the net voltage drop, which is equal to 200 volt across the combination. So VR is equal to I into R, but the value of the current in the resistor is 10 ampere. So therefore 10 into R is almost 9.96. 10 in 9.96. So if you do carefully, you will get, if you do the calculation, you will get 99.6 volt, 99.6 volt. This is a series circuit, right? Inductor and the resistor are connected in series. So if I take this current as a phasor, current as a reference phasor, so the current and the current in the resistor and the voltage across the resistor are in phase. So therefore this is a VR. Voltage across the resistor and the current in the resistor are in same phase. If you see carefully, the current in the inductor and the voltage across the inductor, the current in the inductor lags the voltage across the inductor by 90 degrees. So therefore the current lags the voltage, right? So therefore this has to be the VL. This has to be the VL. The current is lagging the voltage across the inductor by 90 degrees. So this is the net voltage. So this is the V. This is the net voltage drop. Net voltage drop across the voltage across the inductor and the voltage across the resistor. So this is the V. So these are perpendicular, right? So by Pythagoras theorem, V square is equal to hypotenuse square is equal to sum of the remaining two squares of the adjacent. So V square is equal to VR square plus VL square. As we know, value of V is 200 and we also know the value of VR is equal to 91.6. So we need to find the only unknown parameter, which is VL. So therefore VL is equal to under root over V square minus VR square. So the value of V is 200 square. So 200 whole square. 200 whole square minus the value of VR. VR is, which we already got, is 99.6. So 99.6. So if you do this calculation, you get VL is equal to 173.32 volt. So this is the voltage across the inductor. See, the voltage across the inductor, VL is equal to 173.32. So therefore VL is equal to I into XL. So VL is already known, 173.32. And the value of the current in the inductor is 10 ampere. So 10 into XL. So we need to find the value of XL. Therefore XL is equal to, if you do this by division 10, you will get 117.332 ohm. So this is our required solution of this problem. So therefore XL is equal to 117.332 ohm. So we finally figured out the concept, and I am telling you again, the active power is only absorbed by the resistors. The inductor and capacitor won't consume any active power. So therefore the active power is absorbed by two resistors, the resistor 1 and the resistor 2. The current in the resistor 1 is 2 ampere and the current in the resistor in this is 10 ampere. So by this, all these calculations, we got the value of XL is 17.332 ohm. So after solving the previous problem, now let's move forward to the other numerical, which is the question number is 66. This question, they have given a balanced load. Balanced load means the value of the impedance in all this is same. Then only this will become a balanced load. Means I am repeating it again. If the impedance value in these three loads is same, then only this load will become a balanced load. So this load is connected in the star connection, and the common point, this common point is called as denoted by a symbol N. And there is a supply, three-phase supply, which is given as a line. This is the line A, and this is the line B, and this is the line C. In this question, they are given voltage of PAN, means with the voltage across the line and the neutral is 10 angle 15 degrees. And the phase sequence of the supply is ABC. The phase sequence of the supply is ABC. And we need to figure out the line voltage B with respect to C. We need to figure out in this numerical. This is our main aim in this numerical, and this numerical is given in the gate here 2014 for 1 mark. See, I already told you in my previous lectures about the phase sequence ABC means ABC means the phase sequence. I am repeating it again, just listen carefully. Phase sequence ABC means, suppose this is the voltage of this is the voltage in the line A, and similarly the voltage in the line B is with the second curve, and the voltage across in the line C is this one. So A, B, C. The maximum of the first one comes starting, and the other is second, and the later one is third. So, or in other ways, 0. The starting 0 came for the first time of A phase, and the second time it came for B phase, and the third time it came for the C phase. That is the reason the phase sequence is A, B, C. Means B is going to lag A and C is going to lag B. I am repeating it again. ABC means phase sequence means B is going to lag voltage A and C is going to lag voltage B. If you listen carefully, if you know the concept of phase sequence in the three phase supply, the voltages, if they are balanced, they have the magnitudes equal and they are displaced by an angle of 120 degree. See, I am trying it, repeating it again. In a balanced three phase supply, the voltage magnitudes are equal. If this is the voltage V1 and this is another voltage V2 and this is another voltage V3. Suppose this is a balanced supply. The voltage magnitudes are same and they are displaced by an angle of 120 degrees. This is the concept of a three-phase balanced supply. In the three-phase balanced supply, the magnitude of their voltages is same and they are displaced by an angle of 120 degree. This is called as the three-phase balanced supply. Same concept now we are going to apply for this example numerical. If you see carefully, they have given VAN. VAN is equal to 10 angle 15. So I am drawing it in here in the representation. Listen carefully, it will be very easy. If you draw this diagram, then the remaining part is very simple. See, VAN. So VAN is already given, which is 10 angle 15 degree. So as we have kept a balanced three-phase supply, so now the phase sequence VAN we know. Now we have to keep the next one is VBN because B is going to lag A. So VBN we need to find. So similarly VCN is equal to we need to find. Right? As I already told you, in a three-phase balanced supply, the magnitudes are same. So the magnitude in this first case it is 10, then here also it is 10. The third one is also 10. But we need to find the angle. The angle we need to find. And the remaining things are equal. 10, the magnitudes are same. But we need to figure out these angles. See, I will draw it carefully here. See, VAN is 10 angle 15, right? So VAN is 10 angle 15. So this is VAN. The magnitude is 10, which I written by symbol here. And the angle is 15 degrees, means positive direction, means anti-clockwise. This is a 15 degree. But the VBN is going to lag. The VBN is going to lag here. The VBN is going to lag VBN, right? VBN is going to lag VAN by 120 degrees. By 120 degrees means the total, this angle is how much? This angle is how much? 120 degree. So 120 minus this 15. So you will get this angle. This angle as 105 degrees. 105 degrees, right? 105 degrees. And similarly, VCN is going to lag VBN by 120 degrees. Means this angle is 120 degrees. 120 degrees. So 120 degrees plus 105 is equal to 225. The net angle is 225. So I am removing this. What I am trying to say is the phase angle between this is 220 and this angle is between them is 120 and the angle between them is 120. So I will remove this 120 so that now it will be very easy for me to write the notation. It will be very easy. If you see VBN is equal to in the clockwise direction the angle is 105. The clockwise the angle is negative, right? So minus 105 degree. Anti-clockwise the angle is positive and the clockwise the angle is negative. And VCN, this is 120 and this is 105. So the total angle from this positive x-axis to this point is 105 plus 120, which is 105 plus 120 is 225. So therefore, as the angle is from here to here, means in the negative direction, right? From here to here. So it is going to be now 225, right? 225. So it is in the clockwise direction. So it is minus 225. So whenever the whenever we are taking the clockwise direction, the magnitude value is negative. Whenever the sign is negative, whenever we are taking in anti-clockwise, the sign is positive. So we got VN, we got VBN, and we got VCN. So you simple remember one thing, the magnitudes are equal and they are displaced by an angle of 120. But we have to write with respect to the positive x-axis, whether the dimension we have written for this with respect to the positive x-axis. So VBC we need to find. So VBC, the line voltage of B with respect to C is equal to VBN minus VCN. So VBN, already we know, VBN is equal to 10 angle of minus 105 minus VCN. VCN is equal to, already we have figured out, 10 angle of minus 225 degrees. So if you do the calculation, finally we will get VBC is equal to 10 times of root 3 minus 75 degrees. This is our final result. So therefore VBC is equal to the value of VBC, the line voltage of B with respect to C is equal to 10 root 3 angle minus 75 degree voltage. This is the required solution of this numerical. Solve the previous problem. Now let's move forward to solve the other numerical. The numerical number is 67. In this question, there is an ideal voltage source of 1 volt and another ideal voltage source of 1 volt, and there is an ideal current source of 2 ampere, and there are 3 resistors which have an equal value ohm of 1 ohm, 1 ohm and 1 ohm. The aim of this problem is to figure out the power delivered by the 2 ampere. Means we need to find how much is the power which is delivered by this 2 ampere. We need to figure out in this question, and this question is given in the GATE year 2014 for 2 marks. So if you see carefully, there are actually 4 nodes in this numerical. This is a node 1, this is a node 2, and this is a node 3, and there is a node 4. So I will assume the node 4 as the reference node, means 0 potential. The node 4 I have considered it as a reference, means 0 potential. So by nodal analysis, the remaining nodes voltages I must know. We must figure out. If you see carefully, this node voltage, let me assume this is Vx. This is some Vx. Let me assume the node voltage in this point is Vx, and here it is Vy, and here it is Vz. So these are the 3 node voltages which are unknown. We must figure out. If you see carefully, here the node potential is Vx, and here the voltage is 0. So therefore Vx minus 0 is equal to 1 volt. So Vx minus 0 is equal to 1 volt. So therefore Vx is equal to 1 volt, which we figure out. So therefore this node voltage is also we figured out. And if you see carefully Vz, we can figure out Vz also. How means? I am removing this one Vx. See, if you see carefully, I am writing a KVL across outside this loop. In this loop, I am writing the KVL. If this is Vz and if it is 0, so therefore Vz minus 0 is equal to Vz. This is the voltage drop. We can take this node voltage or Vz, or the voltage across this 1 ohm can be Vz, because Vz minus 0 is equal to voltage drop across resistor is also Vz. If I write the KVL in this closed loop, outer closed loop, if I am going from positive to negative, so therefore there is a rising potential which is plus 1. After traveling up to here, again I am going from positive to negative, so therefore there is a dropping potential which is minus 1. And after coming up to here, again I am going from positive to negative, so therefore there is a drop in potential which is minus Vz. So I completed the closed loop. So therefore by KVL, the algebraic sum of net arithmetic voltage drop across in a closed loop is 0. So therefore plus minus get cancelled. So therefore Vz is equal to 0. So therefore Vz value is 0 volt and the Vx value is 1 volt. So out of these 4 nodes, one node is taken as reference which is 0 volt, and the another node voltage is 1 volt, and here the another voltage is node voltage is 0 volt. So the only unknown voltage is now Vy. So apart from Vy, we know all the node voltages. So we need to figure out the unknown voltage which is Vy. So now I am writing the, by nodal analysis, I am writing the KCL across this junction. Across this junction, I am assuming all the currents are leaving. So in this branch, by nodal analysis, I am assuming all the currents are leaving across this node. So as the current is leaving across this node, the current goes from higher potential to lower potential. This node potential is Vy and this node potential is 1 volt. Therefore, Vy minus 1 by 1 plus, in this branch the current is going from Vy to node Vy potential to 0 potential. So therefore Vy minus 0 by 1 plus, see the current entering the node is 2 ampere. So but we need the current which is leaving the node. So the leaving the node has to be equal to minus 2 ampere. So minus 2 ampere is equal to 0. So by nodal analysis, the only unknown parameter is Vy. If you solve this equation, we will get Vy is equal to 3 by 2 voltage, 3 by 2 volts. So finally we have got all the node voltages. This is 0 volt and this is 1 volt and this is 3 by 2 volt and this is 0 volt. So therefore the voltage drop across this current source is Vy, means Vy minus 0 is equal to Vy. So the voltage drop across the current source is, across the current source there is a voltage drop of Vy and the current is 2 ampere. See, the current is going from negative to positive, means this element, this current source is going to deliver the power. So the power delivered by the current source, which is 2 ampere, is the current into voltage. The current is 2 ampere and the voltage is 3 Vy. Vy is 3 by 2. So if you do the calculation, you will get answer is 3 wattage. Means the power delivered by the current source 2 ampere is, the final answer is 3 watt. This is our required solution. So after solving the previous problem, now let's move forward to do the another numerical. The numerical number is 68. This question says that there are two networks N1 and N2. For these two networks, outside these two networks there are certain type of connections, like 3 branches are there. In this branch there is a 3 ohm resistance with a voltage drop of 6 volt, and in this branch there is a resistance of 2 ohm with a voltage drop of 2 volt. Already the polarity is given for these two branches. The voltage polarity is already given in the question. And there is another branch. In this branch there is an ideal voltage source which voltage is 5 volt. And the aim of this problem is to figure out how much is the power delivered by the 5 volts. We need to figure out in this problem. And this problem is given in the GATE year 2015 for 1 mark. So if you see carefully, in a resistor, always the current goes from higher potential to, the current always goes from higher potential to lower potential. Higher potential to lower potential, the current will travel. See here, the voltage drop here is positive and here is negative. So therefore the current has to travel from higher polarity to lower polarity. Means higher voltage polarity to lower potential polarity. Similarly here also the current has to travel from the positive polarity to the negative polarity. So here also the current is somewhat I2. If you assume this is I1 and this is I2, so I am assuming the direction of the current in the 5 volt source is in this direction. Let me assume which is I3. If you see carefully, the voltage current I1 is equal to the voltage drop across the voltage by current. So therefore I1 is equal to the voltage drop across the, which is I1, right? This is I1. See, I1 is equal to the voltage drop across the 3 ohm resistor is 6 volt and the resistor is 3. So 6 by 3 is equal to 2 ampere. And similarly, here in this branch, I2 we need to figure out. So V by R means voltage is, the voltage drop across the 2 ohm resistor is 2 volt and the resistor is V is equal to IR, right? So therefore the resistance across this 2 ohm is 2. So the resistance is of this is 2 ohm, right? So the voltage is 2 volts. So the 2 by 2 is equal to 1 ampere. So So therefore I1 is equal to 2 ampere and the I2 is equal to 1 ampere. See, by KCL, the sum of incoming currents across this node is equal to the sum of outgoing currents. So at this particular node, the incoming current is I1 and the outgoing currents are I2 and I3. So therefore, by KCL, for this network, the incoming current is only I1, but the outgoing currents are I2 and the I3. So therefore, we have to write I2 plus I3. But we already know I1 is equal to 2 ampere and the I2 is equal to 1 ampere. So now the value of I3 is, which is 2 minus 1 is equal to 1 ampere. And the current value which we got is positive, means the direction which we assumed in this branch is correct, or our assumption is correct. Suppose if in this case, if I assume this is as a reverse direction, let me assume this as somewhat in the upward direction, then the current which you are going to get is minus 1 ampere, means the assumed direction is ours is wrong, so we need to change our direction finally. So but in this case we assumed that direction which is already, the assumed direction is always correct because the current is a positive, so therefore our assumption is, the assumption of the direction of the current I3 is correct. So therefore the current is going from lower potential to high potential, so therefore this voltage source is going to deliver power. So therefore power delivered by the voltage source, so therefore power delivered by the voltage source 5 volt is equal to, the voltage is 5 and the current I3 is 1 ampere, so therefore it is going to deliver a power of 5 watt. So therefore this voltage source is going to deliver a power of 5 watts. This is our required solution. So after solving the previous problem, now let's move forward to solve the another numerical. The numerical number is 69. This question says that there is an ideal transformer. For this ideal transformer, it has an inductance, self-inductance of L1. The primary coil has an inductance of L1 and the secondary coil has an inductance of L2. Means there are pure inductive nature. Means the resistance in this transformer is neglected. And for this primary, they have given a supplied voltage source, which has a frequency of 50 Hz. This voltage source has a frequency of 50 Hz. This supply voltage source has a frequency of 50 Hz. And the secondary of this transformer is short circuited. Now, and let me assume the current in this primary coil is I1 and this current in the secondary coil is I2. These are the assumed directions, I1 and I2. The aim of this problem is to figure out what is the equivalent inductance seen from the primary side, seen by this source. We need to figure out, the aim of this numerical is to figure out the equivalent inductance which is seen by the AC source. Here the value of L1, self-inductance of the primary coil is given 800 millihenry and the self-inductance of the secondary coil is 600 millihenry, which is already given in the question, and the mutual inductance between these two primary and the secondary coil is 480 millihenry, and this question is given in the GATE at 2015 for 1 mark. So now we need to figure out the value of the equivalent inductance which is seen by the source. So if you write the equations in the primary side and the secondary side, and by solving them we will get a certain type of equation. By using that equation we can draw the equivalent circuit of this equation, but the equivalent derivation I am going to teach you in my theory classes, which are going to come in the coming days. But until that, just remember this circuit, how to draw it. See, with this circuit, if you write the equations for the primary and the secondary, after solving those equations, you will get a certain type of equation. That equation is going to satisfy the equivalent circuit. This circuit will also satisfy the equation which is given by this circuit. See here, this one is L1 minus M and this is L2. This is L2 minus M. This is the equivalent inductance is L2 minus M, and this is the value of M. See, for this there is a source. There is a source supplied, and this is a secondary which is short circuited. And the current in this branch is I2, and the current in this branch is I1. So, if you write the equations for this circuit, the same equations are going to satisfy for this circuit also. I1 I2 and this is the equivalent. So now we need to find the equivalent inductance of this circuit, right? Equivalent inductance. We need to figure out the equivalent inductance. If you see carefully, this inductance and this inductance are going to be in parallel. So the whole parallel combination is again series combination with the L1 minus M. So if first we need to find the L1 minus M. L1 is 800 millihenry and the M is 480 millihenry. If we substitute 800 minus 480, we will get 320 millihenry. And similarly, if we need to figure out the value of the L2 minus M, therefore L2 minus M is equal to L2 is 600 minus 480. It is going to be 120, right? 120 millihenry. Okay. So L1 minus M is equal to 320 millihenry and the L2 minus M is equal to 120 millihenry. So now we need to find the equivalent inductance. So therefore equivalent inductance is this is L1 minus M is equal to 320 millihenry plus these two are in the parallel combination. So therefore L2 minus M is 120 and this M is equal to 480 millihenry. So therefore 480 into 120, the parallel combination, right? So product by sum, 480 plus 120. If we do a calculation, we will get the value is 416 millihenry, 416 millihenry. So therefore the equivalent inductance after calculating, we will get the value is 416 millihenry. This is our required solution. Again I am reading it here. See, if we write the equations for this loop and the equation for this loop by including the mutual inductance, after solving those equations, we are able to draw this circuit. Means the current, if the equations which are going to get here, we will be able to draw this circuit. So writing those equations in this lecture makes the video lecture lengthy more. So that's why I will make these derivations in my theory classes which are going to come in the coming few days. Already solving the previous problem. Now let's move forward to solve which is the last numerical in this lecture. And the question number is 70. If you see this circuit, in this circuit there is an ideal voltage source, the value is 4 volt, and there is an ideal current source, its value is 5 ampere. And there is a resistor of 2 ohm, and the voltage drop across is given just plus minus V0, and the polarity is also given. And there is a resistance which value is 5 ohm, and there is another resistor which value is 10 ohm. And there is a voltage dependent current source. The current source value depends upon certain voltage, which is the voltage drop across this 2 ohm resistor. And they also given the power dissipated in the 2 ohm resistor is 12.5 watts. And the value of K is always positive in this question, and we need to figure out what is the value of K. And this question is given in the GATE year 2015 for 2 marks. So let's get started. If you see carefully, here they have given the symbol plus minus polarity, means the always current goes from higher potential to lower potential. So let me assume the direction of the current is high. This means the current is traveling from higher potential to lower potential. As they already given the power absorbed by because the resistor always absorbs the power. So therefore the power absorbed by the 2 ohm resistor is 12.5 watt. So therefore power absorbed by the 2 ohm is equal to, which is already given, just 12.5. So therefore power is also given by the equation which is I square R, means V voltage across the resistor and the current in the resistor. Or another way we can write it as I is equal to V0 by R, so therefore we can also write it V0 squared by R. If you see carefully, as the R value is known, we need to find the value of V0. So therefore 12.5 is equal to V0 is V0 we don't know, we need to find V0 square, but the R value is given, which is 2. So if you do the calculation, V0 is equal to root over 2 into 12.5. 2 into 12.5, if you do this simplification, V1 is equal to plus 5 volt. So therefore the value of the voltage drop across the 2 ohm resistor is plus 5 volt. So the voltage drop across the 2 ohm resistor is, which is 5 volt. So therefore the current So therefore the current in the 2 ohm resistor is voltage divided by the resistor. But the voltage is 5. So the 5 by the value of the resistor is 2. Therefore 5 by 2 is equal to 2.5 ampere. So by KCL at this node, the sum of incoming currents is equal to sum of outgoing currents. As there are only two currents which are coming inside the junction and there is only one current which is traveling outside the junction. The incoming currents are I ampere and the another is K into V0 ampere. And the outgoing current is 5 ampere. So by KCL, the sum of incoming current is equal to the outgoing current. So the incoming current are I and KV0. So I plus K V0 is equal to the outgoing current is 5 ampere. And I we already figure out which is 2.5. And we need to figure out the value of K. But already we know the value of V0 is 5. So therefore 5 into K is equal to 5K, which is equal to 5. If you do the simplification, there is only one equation with only one unknown which is K. So if you do the simplification, the value of K is equal to 0.5. And the value of K is always, in this problem we got the value of K is positive. So our final result, the value of K is 0.5. This is the required solution. So by this lecture, we have successfully completed 70 numericals. And I am very much excited to teach you all the previous year questions of network theory in the coming days. If you like the content of this lecture, then please do like, share and subscribe our YouTube channel so that we will get more motivation to do these type of videos in the coming days. And don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to your mobile. If any improvement needed in our lectures, the content of our lectures and the teaching style, then please do comment in the comment section and we will read each one comment. Thank you so much for watching this lecture, and in this COVID-19, stay home, stay safe.